இதுல ப்ராப்ளம் இல்ல. Meeting is now live streaming on this one.
வந்துருச்சா?
வந்துருச்சு சார்.
இது அது ஒரே லிங்கா தம்பி, வேற லிங்கா?
சார் வேற லிங்க் சார்.
YouTube லிங்க்.
சார் வேற லிங்க் சார்.
சரி.
லிங்க் நீ போஸ்ட் பண்ணும்ல குரூப்ல.
ஆமா தம்பி
நான் போஸ்ட் பண்ணிடுறேன் சார். நான் அந்த மெசேஜை டெலீட் பண்ணிட்டு.
ஆமா அந்த மெசேஜ் டெலீட் பண்ணிட்டு இந்த இதை போடு. ஆமா ஆமா
Good afternoon, ma'am. Good afternoon, sir.
Good afternoon, ma'am.
Good afternoon, sir.
சார் லிங்க் நான் அப்டேட்டட் லிங்க் நான் குரூப்ல போட்டேன் சார்.
அதை டெலீட் பண்ணிட்டல ஜெரஷன்?
பண்ணிட்டேன் சார், டெலீட் பண்ணிட்டு தான் சார் போட்டுருக்கேன்.
சரி. மேம் ஓகே தானே?
ஓகே
சார் ஓகே தான் சார். ஸ்ட்ரீம் ஆகுது சார்.
We'll start the program when once Dr. Jaya ma'am joins. Ma'am,
Hello.
good afternoon, ma'am. Good
Good
afternoon, ma'am.
afternoon. Good afternoon. 1 minute. I'm
Yes,
coming.
yes, ma'am.
Yeah. Emma,
Yes, ma'am. You are,
can you see me?
yes, ma'am. We are able to see you.
Hi. How many participants? 6
Ma'am,
participants.
actually, no, ma'am, this is in Zoom, ma'am. Otherwise, it is going live on YouTube, ma'am. We have around 400 participants who have registered.
100.
Yes, ma'am.
Now you
So,
started streaming?
we have started streaming, ma'am. So we will directly go into the program, ma'am.
Yeah.
I'll give a brief introduction and then we'll go to the program. Yes. A very good afternoon to all the faculty members and all the people from industry who have joined us for this faculty development program on disaster management and mitigation. This is our second day, and we warmly welcome you from Karunya Institute of Technology and Sciences. The speaker for today is Dr. KP Jaya, and I will give a brief introduction about her. Dr. KP Jaya is currently the director for Center for Research, Anna University, Chennai, and I guess most of you may be knowing her because most of you will be doing your PhD under Anna University. She did her PhD in structural engineering from IIT Madras, and she has 25 years of teaching and research. Currently, she is a professor in the Structural Engineering Division, College of Engineering, Anna University, Chennai. She is a panel member of CED 39 Earthquake Engineering Code, BIS, and in CED Cement and Concrete, CED 2 Cement and Concrete Codes, IS 456 in BIS. She is also the chairperson of Indian Concrete Institute, Chennai chapter, and she is also an independent director of the Tamil Nadu Police Housing Corporation from 2016 till date. She was a panel member for the preparation of a precast handbook and Indian Concrete Institute Initiative, a technical committee member for the preparation of guidelines for construction of houses affected by tsunami in Tamil Nadu in 2005. To her credit, ma'am, to her credit, she has more than 100 journal publications, 150 conference proceedings, and she is a reviewer in seven journals, and out of which 2 are in AAC, and consultancy and research. She has done around 10 projects, and she has completed from her around 10 candidates. She has produced PhD candidates, and she is currently guiding 10 PhD scholars. And I am proud to introduce her because out of the 10 PhD completed, I am the first candidate of Madam. Thank you, Madam, for accepting our invitation and presenting and being here to present your lecture and share your expertise. I welcome now Dr. Jaya to give her a lecture. Ma'am?
Yeah, thank you, Hema.
Yes,
Sorry,
ma'am.
Dr. Hema.
Ma'am, it's okay, ma'am. I'll be a student, ma'am.
Yeah, it's my proud that you are my student. You are heading a department. And actually, really, it's a very proud moment. And you are, to my understanding, you are so cordial with your staff colleague, and you are running the department very nicely. Nice
Thank
of
you,
you. And I am extending my sincere thanks for inviting me for sparing some time with you. Thank you.
Thank
I'll
you so
straight away go to my lecture because
ma'am.
Zoom, the time limit maybe 1 hour max.
No, ma'am, we don't have time limitation, ma'am. So we can go ahead, ma'am.
Okay. Thank you for your nice introduction. I'll start
Yes.
my lecture.
Yes, ma'am. Yes, ma'am. We can see your screen, ma'am.
Yeah.
Yes, ma'am.
Is it visible?
Yes, ma'am. It's visible, ma'am.
1 minute. Okay. Yeah. The topic of today's lecture is on retrofitting strategies post disaster. So I am very much proud to say that I'm professor in structural engineering, and the additional responsibility is Director Center for Research, Anna University. And I'll just start with a preface on what is retrofitting, which is refers to the additional of new technology or features to older structures. That is what is retrofitting. The system, basic system can be anything like building or gadgets or whatever it be. And scope of the present discussion is limited with buildings. So we are structural engineers. We should know how we will retrofit back our structures which has been exposed to disaster. Disaster can be anything, like what the next slide says. It can be an earthquake, and it can be any tsunami, which is a subsequent effect of earthquake or cyclone. At the end of any disaster, what is left out, you can see the debris and a mother and a child. And at the end of disaster, the child is looking at us, how you are going to save us from all these calamities. Unfortunately, we can say that we cannot save people out of these calamities. We have to live with the calamities. And after once it is passed by, we have to retrofit ourselves. Like what is we are experiencing now, the corona effect. After, like saying is there, any time will pass by. So this also will pass by. We will look forward with a positive attitude. Okay, this is the effect of earthquake. What is the after effect of earthquake? We will be left out with the damaged structures and some debris, which is seen at the last slide. And what are the general lessons learned from the past disasters? I'm just focusing on earthquake, which is my focus area. You can look into those pictures. This is a very, very old picture which has been taken from our Bhuj earthquake, which has happened in 2001. That is the very heaviest or damages earthquake we have experienced. This is what is called the soft story effect. You can see there was one floor here. It's an open ground story which is having a less stiffness, which has been led to the failure of this particular structure of being a soft story. So you can see this is a ground floor roof that is sitting on the ground. So this is the basic fundamental philosophy of damage in case of structures with a less stiffness at the ground story. It will act as an inverted pendulum, which this columns is unable to withstand the load coming from the top. So this is one type of damage. This picture is taken from, as I mentioned earlier, in 2001 Bhuj earthquake. Till the occurrence of that Bhuj earthquake, we Indians are least bothered about designing the structures for the lateral loading. So after that, people started thinking a lot, and they came out with the proper solutions for building the structures itself as earthquake resistant. Now you see the second figure. This is again the soft story effect. You can see here, this is the discontinuity of shear wall. You can see here, this is a shear wall which has been curtailed at the roof of the ground floor, and this is the transition girder. The shear wall is resting on the transition girder. In turn, the transition girder has been supported in the column. So what is the end of this philosophy? The combination of the stiffness offered by these two columns are lesser than the stiffness offered by the shear walls. Hence, the columns are getting damaged. You can see here the concrete has been spalled off and the reinforcement is exposed. So finally, the structure has failed. If the column fails, yes, once and all, the structure will get failed. This is also one type of soft story failure. You can see here this one, irregularity in stiffness. You can see here, this is a short column effect. Generally, it is called a soft story. What is happening here in the soft story? This is a one-story column. Unfortunately, somebody has filled in half the height of the column with some infilled brick masonry. So this unsupported, laterally unsupported column become a short column, and the shear forces coming at the top and bottom of this short column become enormously high, and which will lead to the failure of this short column. So this is a soft story in what I can subsequent effect of the short column effect. So Finally, what will happen after all, end of all these disasters, the column will get failed. This is the top of the column and this is the bottom of the column. So the reason for this column failure is generally due to the shear accumulation of the shear, as well as the bending cracks developed at the top as well as bottom of the columns. Here you can see the vertical longitudinal reinforcement has been buckled and the stirrups has been opened up, and we have to go about with the total supporting system of the column supports, like confining of column reinforcement and concrete and all those strategies has to be developed. But if at all some little bit of cracks developed, we should have a provision to retrofit it. I'm just telling about what are the failure pattern, expected failure pattern of structures. This is the failure pattern of shear wall. Generally, there is a saying like the structures can be saved by introducing shear wall into the system. That is a solution, but unfortunately, if the detailing of the shear wall is not proper, so, or I can say that inappropriate reinforcement detailing of the shear wall will again lead to the failure of the shear wall, which will lead to the failure of the overall structure. So we have to take much care and importance in detailing of the reinforcement in case of whether it is a shear wall or a column or beam column joint. Next slides tell you about what is the pounding effect. Pounding means hitting each other. Hitting each other is happening only because when the seismic gap between the structures are very limited. So there is a particular clause in IS 13920 that we have to provide seismic gap, sufficient seismic gap between the buildings to accommodate the deflection during the lateral loading. Here, this picture shows the effect of improper connection between the structural elements. You can see here, this is nothing but a shear core, which is the lift core in the building. And the lift core has been supported, this diaphragm, sorry, the diaphragm got supported by the lift core. At the end of the earthquake, all the supporting elements, diaphragms supported by the shear wall has been fallen down, and only as say like our spinal cord, only the shear core or the shear wall is standing. So what is the reason for it? The improper connection between the shear wall and the diaphragm, which is getting connected with the shear wall. This picture has been what I can say, introduce some fire into my mind, which is lead to the give this as a research topic to one of my research scholar, and she has come out with a very proper detailing between the shear wall and diaphragm. Okay, next is the improper connection between the precast structures. You can see here, this is the precast plank, this is the precast beam, and here you can see the precast column, and this side and this side. This is the precast wall panel also. And during the earthquake, what will happen? This column may be deflecting towards this side, and this column may be deflecting towards this side, which has lead to open upping of the top surface of the structural elements, structural system. So these planks will lose the supporting base from this portion and will fall down. Just look at the structural elements, precast elements. All elements are very strong and intact without any failure. But what has failed? The connection has failed. At the end of the day, the structure has failed. So we need to give proper connection detailing between the precast structures too. So what is the remedial measure? I have discussed about what are the failure pattern of during the disaster, especially lateral loading. Either it can be either earthquake or wind. This is the different types of failure which will be experienced by the system, and what is the remedial measures to arrest or avoid such failures. For existing structures, we can go with the retrofitting. If the structure is experiencing very limited level of damages, which is serviceable even after the earthquake, we can go with the retrofitting. In case of new construction, we can go with three types of strategies: proper detailing, proper planning, and selection of appropriate materials. So today's lecture is focusing on this part, how we can avoid failure after failure of the structures which experiencing very limited level of damages and which can be retrofitted back and can be put it into use after earthquake. So phases of retrofit program. So you can see here, these slides show you what are the phases which has to be accommodated in case of retrofitting. First thing is vulnerability evaluation. Vulnerability evaluation means what is the level of damage possibility for a structure. This can be evaluated by considering the structural vulnerabilities of the overall system and the seismic hazard prescribed for that particular site and socio-economic consequences. These three items will decide what is the vulnerability of that particular structures in the area under consideration. Now you look into this, next step is the evaluation of the existing system. System means system capacity. We have to evaluate what is the overall capacity of the global system and what is the demand, seismic demand. If some earthquake happens after 10 years, what will be the force exerted on the particular structure which is retrofitted? That is nothing but the seismic demand. There should be a proper ratio between the demand and capacity. Demand should be much lesser than the capacity. That ratio matters a very, very high importance into the system and the selection and design of retrofit measures. So member response we should analyze and global response we should analyze to choose what is the retrofitting measures to be adopted for the structural global system. And the implementation. Implementation is very, very important. We should find out a very talented, experienced firm to execute the work. And resource evaluation, we should evaluate what is the resource capability of that company, and multi-phase program. It is a multi-phase program. Definitely, we have a lot of things to do while implementing the retrofitting methodologies. This is the overall phase of retrofitting program. First is vulnerability evaluation, evaluation of the existing system, and define the capacity, demand capacity ratio. And ultimately, based on the demand capacity, we should choose what is the design retrofitting measures which we have to adopt and choosing the appropriate executing agency. You see here, first thing is seismic vulnerability evaluation. We should evaluate what is the site-specific hazard. It is based on the local soil condition and soil response and failure. You can see here, this is the source and this is the path. This is very much concerned with the local soil conditions. If the soil is in the nature of enhancing the, what I can say, tremors developed at the focus area, definitely whatever be the excitation reaching at the base of the structure will be high. Where it can, the soil property can either amplify or attenuate the, what I can say, effect of the earthquake happening, which is getting transmitted to the soil and hitting the structure. So the local soil conditions has an important role on deciding on what is the excitation experiencing by this building, and soil response as well as the failure of the soil. If it is in a very hilly area, the soil can experiencing some sliding. So that all lot of issues. You can see the next slide. Due to the soil condition, the structures can experience this type of bulging of soil and leading to the failure of the structure. So this is what is the evaluation of the site-specific hazard. Soil condition is very important role in developing these type of damages to the structure. And come to this evaluation of the structural vulnerability. We should evaluate what is the capacity and what should be the end of the day, what should be the demand, what will be the demand on the structure. Based on that, we have to identify the appropriate geometry. The geometry has to be, what I can say, it's symmetrical in plan as well as the verticality. And when you are evaluating the structural stability or vulnerability, the date of the design and construction is very, very important. What is the residual strength of the structure has to be evaluated while to arrive at the demand capacity ratio. So This is the global vulnerability evaluation strategies. And when you come into the local level or elemental level, what are the vulnerability evaluation? We have to concentrate on these columns. Different elements are there, columns, beams, like that. First, I'm talking about this column. You just look at this picture. This damage is due to inadequate confinement, inadequate shear strength, and local and strength, location and strength of lab spices. So these are the reasons for the failure of this particular column. In order to avoid this type of failure, what are the strategies we have to adopt? We have to adopt that or while doing the retrofitting. Next comes to the beam. Just look at this beam, the failed beam. It has failed at the top surfaces, and you can see the shear cracks in these beam surfaces. This may be due to that reduced flexural strength, or I can say that insufficient bar anchorage, inadequate shear strength. That has led to the failure of the structure with the development of shear cracks here, inadequate strength in torsion. It is subjected to torsional warping also. So all these things, flexural, shear, and torsion, has caused the failure of this particular beam. So this, again, we have to identify proper retrofitting strategy to regain back the strength of this particular beam. Then look at the joints. Joints is very, very critical, crucial locations. You see here, this is the beam column joint. This is the column and the beam. Due to the shear cracks development at the joint region, the joint has experienced the sprawling of concrete. The shear reinforcement has been exposed, and there is a possibility for retrofitting this particular joint. And this says what is the reason for failure of this joint region. So when you are retrofitting the joint, we should look at the reasons for failure. We have to attack the reasons from the root cause to avoid from the root cause and do the retrofitting methods. Now comes to the foundation. Look at this. The foundation totally, this reinforcement has been totally taken off. The anchorage, there is no proper anchorage or bond contact between the reinforcement and the foundation. It's totally toppled off. This type of failure is due to insufficient flexural strength, inadequate shear strength, inadequate anchorage. These type of failures lead to the strategy like how we can find out a proper strategy to retrofit the systems. So retrofitting techniques. What are the different types of retrofitting techniques? You look into the methodology, strategies like that. You can see here like replacement of concrete members. That is the first thing. That is nothing but the replacing method. You have the columns with the dimensions 300 by 300 or something like that. We will replace some part of the concrete and we'll add some also with a higher strength of concrete. That is what is called the replacement of concrete members. Or sometimes we will replace column with shear wall. That is also comes under this category. And addition of concrete sections. Either we can do an overlaying method or jacketing. Overlaying or jacketing in the construction, we generally call that as RC jacketing or steel jacketing or FRP jacketing or whatever be the material used. Accordingly, we'll name the method of retrofitting. The addition of members, vertical girder addition method. So if you feel like the particular floor is having a lesser stiffness, we can add additional columns. That is the vertical girder addition method. And if you have a necessity to add support points, in case of some beams, if the length of the beam is too high, there you can add a column. The span of the beam is too high, you can add a column in between, but accordingly we have to do some retrofitting or the reinforcement detailing pattern into the beam where you are adding the supporting points. So that is what is called a support method. And addition of retrofitting members. You can see here steel plate bonding method. I'll show you one case study with this. And the fiber reinforced plastic bonding, FRP plastic bonding method, and steel plate jacketing method of construction. And these are all what I can say, passive methods. We are not imparting any forcing system while doing this retrofitting into the system. But you can see at the last, that is, we can introduce pre-stressing into the structure to create the retrofitting, or we can impart additional strength to the global system by imparting pre-stressing. So these are the general methodologies. One by one we can discuss in the next slides. You can see here. So how we can approach the retrofitting method? There are two basic strategies, like global method as well as local method. Global means two main category: conventional method and non-conventional method. You can see here the conventional method is, as I told you in the previous slide, we can add additional shear wall, additional infill. These two will add additional stiffness to the floor, where if we are constructing additional shear wall or infill. This additional infill, the methodology has been adopted in some of the building in Bhuj area after the earthquake. And while imparting additional infill will enhance the stiffness in that particular floor. And adding bracing also will impart additional stiffness to the system. And sometimes this bracing can be like a damping system we can introduce. Thereby we can impart, what I can say, some system which is capable enough to dissipate the energy which is hitting on the structure. And adding wing walls, additional wing walls will give additional stiffness to the system. Wall thickening and mass reduction. That is a very, very innovative method. Mass reduction, we can reduce the mass overlaid on top of the vertical elements. Thereby we can safeguard the system. And why? Because this mass will, what I can say, external force, either wind loading or earthquake loading is directly proportional to the mass and acceleration. If we can reduce the mass, in turn we can reduce the force on the system. And okay, fine. Come to the non-conventional system, supplement damping. If we are providing a damping through the dashboards into the system, I'll show some pictures in the coming slides. And that will impart, what I can make the structure to dissipate more energy. And same thing is with base isolation. Base isolation provide a sufficient strategic method to dissipate energy at the base itself without attacking to the structure. And the structure itself will not undergo any type of deformation if we can introduce an isolation at the base. And local or element level retrofitting strategy can be adopted, like jacketing column, jacketing beam, and jacketing joints, and strengthening the foundations. This is the difference between the global as well as the local system. In the global system, we are attacking the overall system. The performance, we are enhancing the performance of the overall system. In the local retrofitting, we are enhancing the performance of the individual elements. Now I'll attack on global retrofitting strategies. You can see here, this is what I told. This is the building. It's a retrofitted open ground story building after the Bhuj earthquake in 2001. You can see here, this is an additional brickwork. Here also you can see additional brickwork. This is a residential building which has been given, what I can say, parking space at the bottom floor, thereby given opening at this point and this point. During the analysis of this particular structure, it is understood that the bottom story is having a less stiffness compared to the top story. You can see here all the, what I can say, intermediate portion between the columns, the first floor as well as the second floor has been filled with the brick wall. But in the bottom story, only one column was there and another column was here. And this particular portion was open and thereby led to a lesser stiffness at the ground story. And after analysis is understood that it is not necessary that all opening has to be closed. You can see here, this particular opening, still it is opened. And we can identify appropriate location where we can provide an infill to enhance the stiffness of that particular floor. Accordingly, we can fill in with the brick masonry. This is only brick masonry, not reinforced concrete or nothing like that. This will improve the stiffness of the ground story, thereby lead to the safety of the system. This is the installation of masonry wall to enhance the overall performance of the structure in a global strategic manner. This you can see here, installation of new shear wall. We can introduce, here you can see before retrofitting, this area were infilled with the brick wall. In order to improve the stiffness of the system, this infill walls with brick has been replaced with the RC shear wall. This is the installation of new shear wall. This shear wall you can see here. In this particular case, the column has been supported on an isolated footing. This column has been supported on an isolated footing. And in this case, this two has been combined with the additional foundation at this area. And the shear wall reinforcement need to be extended to the bottom foundation to get the sufficient strength to the system. So this is the another methodologies. I have taken this courtesy is Professor C.V. Amuthi. He is the pioneer in the area of earthquake engineering. So these are the strategies has been suggested by the earthquake community to enhance the strength of the structures with the introduction of shear walls. Now comes, while introducing the shear wall, you can see here, this has to be properly stitched. This is the boundary element. This would have been a column at the extreme end. You can see the previous slide. One column is here, another column is here. The reinforcements from the shear walls need to be stitched with these columns on either side as well as the beam on the top. That is the picture shows in this slide. You can see here, this is a new shear wall. All these, what I can say, this is the existing frame, this is a beam, and this is a column. And this is the introduced shear wall, which has to be linked with the existing element through dowels, which has to be passed through the beams. So for that, we need to drill the holes through the beam without disturbing the existing longitudinal reinforcement of the beams. So these are the dowel bars, which is introduced to connect between the existing frame to that of the newly introduced shear wall. This is very, very important. Dowels through existing structure, whether it is through the columns or through the beams, it has to be extended full-fledged. This is the earlier frame. Into that, these beams has to be drilled to introduce this shear wall. And in addition to all those things, the shear wall will have its own reinforcement. So this should be the strategy to be adopted by installing the new shear walls. Comes to the picturization, that is the typical symbolic representation. This is the actual picture from the site. This was the earlier available column, and here also additional column was there. This is a newly introduced shear wall. You can see here the reinforcement as passing through these beams as well as the slabs. You can see here the shear wall reinforcement has been drilled through the slab area and protruded outwards. And intermediate area, this beam area will be introduced with additional shear dowel bars. You can see this is nothing but the global retrofitting using braces. This is an open area, open space between the columns, and here also it's open. This can be introduced with the braces, which will in turn increase the stiffness in this particular area. It is not mandatory that all opening need to be retrofitted with the braces. We can judiciously decide which area to be improved with its stiffness with the introduction of the braces. This is very much available in the market. You bring it and properly connect with the vertical element and the horizontal element. Copper anchorage has to be provided. So there are different types of braces. You can see here. This is concentric braces. You can see another eccentric braces, K braces. These are varieties of braces we will be able to introduce into the system. You can see here, as Hema has mentioned, she has worked with me for her PhD, and she has introduced some tune mass damper for her work. The tune mass damper is nothing but the water tank on top of the building. So she has identified the proper location where the bottom deck has to be introduced to impart the tuned mass effect into the structure and thereby reducing the vibration into the system. So I am very much I am highly proud to say that she has done her work very well, and her evaluation was also by a very reputed examiners from India as well as abroad. And now comes to the base isolation system. You can see here, this is the base isolation strategy which can be adopted. You can see this picture. What is the period of vibration has been affected? This is the time period mentioned on the bottom, and this is the what I can say spectral acceleration on the y-axis. You can see, you can look at this picture. This is the deformation of a strategic building. This picturizes the deformation before base isolation. You can see each and every flows is subjected to deformation. This column also undergone deformation. It is overall tilting of the structure has happened. You can see at this picture, this is nothing but response spectrum. You can look into this. If it is a fixed base that for a time period is very, very low with a high SA value, when it is getting a base isolated, this is a safety limit dot mark has been put. And when you isolate, what will happen? The time period has drastically increased and the spectral acceleration is come down like anything. They were reducing the acceleration and the force coming into the system. When you look into this base isolated system, the total structure is moving to and fro without imparting any deformation to the system. This in this case, not the structure without base isolation is subjected to a deformation all throughout the height. But once it is base isolated, the structure is not at all subjected to any individual deformations. As a whole, this is moving to and fro and leaving out a safe structure for the future use. Now, what is the strategy? Which strategy we have to adopt for retrofitting? Can we see from this picture? You can just see here what are the effect of global retrofitting strategies. When you are introducing, this is the original frame. When you are introducing some precast panels, the stiffness has been increased a little bit. When you introduce a steel brace, again it is increasing, and there the stiffness is increasing, your deformation is getting reduced. When you introducing a concrete blocks, again this is the retrofitted performance of the system. You can see here the lateral force is increasing, lateral drift has been reduced. When you are imparting more and more retrofitting strategies into the system, this is the monolithic wall, which is causing a lesser deformation but a higher lateral force resistance system. But you look at this one, the steel frame brace. This has given what I can say. When generally we'll say that for earthquake resistant structure, it should be more ductile as well as should have more strength. And in this case, this gives both the things. This is undergoing a maximum deformation without losing its strength. So finally, I'm suggesting steel framed brace system may be the best solution for retrofitting, but definitely it will cost a high. So it depends upon the client's requirement. We can adopt anything from this various retrofitting methodologies. And this I was talking about the global retrofitting. When it comes to the local retrofitting, how we can impart in local level, you can see in this picture, strengthening of the column can be either by concrete jacketing, steel jacketing. Hema, are you there?
Ma'am, I'm here, ma'am.
Okay, so how much more time will you give me?
Ma'am, you can take, ma'am. Another 20 minutes is there, ma'am. Okay,
fine. It's audible now, Hema?
Yes, ma'am, it's audible, ma'am.
Definitely, it is quite difficult to take without seeing the audience.
Okay.
So strengthening of column either by concrete jacketing or steel jacketing, fiber reinforced polymer sheet wrapping. So nothing but FRP wrapping, and ferrocement jacketing, pre-stressed wire wrapping. These are the various method adopts for strengthening the columns. This is, I have taken this picture from IS 13935/1993. So it is shows a clear picturization. The dotted one, this area one which I marked as one, it is nothing but the existing column. This is the jacketing area. While jacketing, you have to introduce additional reinforcement. This is the additional reinforcement you can see here. Number 3 is the vertical longitudinal reinforcement, which is added additionally for this jacketing concrete. And this is nothing but the number 5 is nothing but the hole, which is, see, these vertical elements has to be bounded by stirrups, and this is the jacket which has to be integrate with the existing column. That's why this port has been introduced, and these are the dowels which is connecting between this existing column and the jacketed concrete. So this is the method which is suggested by the IS code method itself. Here we have to think about, this is a actual picture where the strategy, what I can say, retrofitting strategy. This is the existing column. This is the jacketed concrete. Here there are some few what I can say precautions we have to take. Minimum thickness should be 10 mm for cast in situ concrete and 4 mm for shotcrete concrete. And adequate shear keys has to be provided to what I can say introduce proper integrity and compatibility between the existing column and the jacketed concrete. And this is nothing but steel jacketing. You can see here, similar to the previous one, this is existing column, and we can introduce the jacketing with the steel sheets, and which has to be connected. Here you can see the angle, steel angle, which is getting imparted to the concrete area, and these are the shear keys which is connecting this concrete and the connecting element and what I can say existing column. And you can see here there are steel can be attached to the column or the beam column joint region with various type of what I can say configurations. This is the steel strip jacketing. You can see here one steel, this is a joint jacketing. Steel strips will be provided, and here steel sheet and steel corrugated sheet. This is nothing but the research work carried by one of my research scholar, Jessie, and she is working with the Hindustan Institute. And the specimen retrofitted with the steel strips has performed very well. Means this one in 2-3 aspects. That strips is economical as well as the performance also nice, because it has undergone a proper ductile linear non-linear behavior pattern. It has been expressed, so this has been given most better solution. And this is nothing but the FRP jacketing. This is a column which is wrapped with FRP, and this is at the initial stages. Here you can see the wrapping wrapped columns, and come to the next slide. This is a jacketing of the beam column joint, RC jacketing. It is exposed. The beam column joint has been exposed. Additional wrapping reinforcement has been provided, and later part it has been concreted. Now come to this strengthening of the beams. Again, addition of concrete, steel plating, FRP and FRP bars. This is FRP bars. Externally, it can be introduced and it can be concreted with the proper concrete with appropriate strength, and external pre-stressing also can be imparted for strengthening the beam. This is again the pictures taken from IS 13935/1993. You can see here, while retrofitting the beams, you can any one of the strategy you can choose. If it is rounded about throughout the beam, you have to run this reinforcement, whatever be the confining reinforcement or stirrups, has to be run through this existing slab and taken it out like this. Here it has to be, the stirrups has to be taken through the beam, and this is the jacketed concrete. This case, but if you need a wider beam, there you can go with this type of, but there should be a limit for the additional thickness for this additionally added beam jacket. So we have to take all precautions which has been prescribed by 13935. with respect to the strength of the concrete, strength of the steel adopted, there should not be a big disparity between the steel of the existing element and what you are adding to the system. And this is nothing but the picture for FRP wrapping. You can see here, there is a necessity to clear the surface and wrap the FRP. And this is the bonding agent. The main problem with this FRP wrapping, it will subject to the lamination of the wrapped system. And it is generally prescribed to use at the round with elements with rounded edge. You can see here, you can see the sharp edge over here. Once it is subjected to some level of loading, this sharp with the higher stress concentration area will lead to the delamination of the jacketed FRP. So we need to be more careful in that area, and as well as developing the surface in which the FRP has to be bonded has to be appropriately managed. This is nothing but a structure which has been developed all retrofitting strategies with the FRP bonding. The building is from Nevada, Las Vegas Panorama condominiums. So you look at this beautiful structure which has been retrofitted after the event of earthquake with FRP bonding. So one case study which I have taken from High Tech Solutions Chennai, they have imported steel jacketing for, there are 2-3 case studies are there. This case study with respect to steel jacketing, I will just show what exactly they have done at the site. This is the building where they have imparted this steel jacketing philosophy. You can see here, this is the surface preparation. You can see all these comps they have introduced, all the depressions, and the surface should not be smooth to accommodate the steel jacketed sheet. So there they have to prepare the surface. They are doing that work. You can see here, after the preparation, they have to check whether the surface is smooth and level. You can see here. And after that, they are preparing the steel sheet, which dimensioning and surface clearing and all those things. You can see all those things. These holes are nothing but to pass the AC duct or whatever it be, the MEP lines has to be passed through the beams. Accordingly, they will put the hole in the steel sheet also. They are preparing the sheet. And this is so cutting wherever they need some additional cutting, or you can see here, they have marked the holes and they are doing this cutting process. Again, it is a preparation of the sheet for fixing in the beam. So surface preparation, they are doing all these type of, it should not be corroded later part. So they are treating the surface of the steel sheet and fixing on the beam. You can see this is the beam which is running. You can see the bottom of the beam, and the surface has been properly treated, and the surface of the steel also has been properly treated and fixing at the face. And here you can see all different types of work carried out. This is the surface on which they will put the bonding agent, and they are fixing, and sufficient shear keys to be introduced between the steel plate and the existing beam. And you can see here the process fixing of the steel sheet beam. And at the end, this is nothing but the retrofitted beam. And here you can see the steel sheets, and on all the sides, you can see all these things are nothing but the shear keys. And this is a supporting haunch for supporting the steel sheet at the end-to-end connections are ready. So it is a retrofitted beam. Very much, I am just give my gratitude to the High Tech Solution who have shared all these slides to me. And the next step is FRP wrapping. This is nothing but the FRP, and they will prepare the surface of the beam, and they will provide this FRP. You can see here, these holes has been provided to pass these MEP lines. See, this is the final look of that. And after this, they will do all the painting work on top of this thing. This is the FRP wrapped retrofitted beam element. You can see here all the type of the fixing of the FRP is very, very important. It should not leave out any single air gap between the surface and the FRP. Otherwise, there is no point in doing this. This is a very, very a crucial and critical retrofitting strategy for RC jacketing is a very straightforward method. Generally, the failure of retrofitted element will be very, very less for the RC jacketing retrofitting methodology compared to FRP wrapping. So you can see here, this is the final look of that. This you can see all these fibers are protruded out of this. This has to be properly treated and proper adhesives has to be adopted while doing this method. You can see here, this is the sequential process of FRP wrapping. And this is just like that. I have put a slide on, I'm not going to discuss anything on more about this. This is nothing but the seismic retrofitting of freeway structure. And so this is nothing but you can see here, this is the original concrete column. This is the grout and this is the steel casing. The grout is an intermediate element between the original concrete column and the steel casing. So this is one methodology which has been adopted for the retrofitting of the freeway structures. This is nothing but the bridge structure and retrofitting of the pier elements supporting this. And what is the final goal of all this retrofitting? It is to ensure an increased lateral strength and stiffness of the building, and to increase the ductility of the building, also to increase the integral action and continuity of the member in the building. We need definitely a what I can say compatibility between the system, and to eliminate or reduce the effect of irregularities. This is very, very important. Irregularity in the form of vertical stiffness or lateral load resisting system, or we have to find some solution to avoid these type of irregularities and to enhance the redundancy in the lateral load resisting system. Enhance the redundancy means anything happens to one element, the remaining elements has to have the capacity to withstand the lateral load. That will lead to the safety of the system. So to enhance the redundancy in the lateral load resisting system and to ensure the adequate stability against overturning and sliding. This is the final goal of retrofitting of any system. And these are the references: ACT, FEMA, IS codes, GOL, and Ahudaja Mukherjee. They have done a lot of work in that area. Thank you so much. Over to Hema. Any questions from the audience?
Yes, ma'am. Thank you so much for your very informative presentation, ma'am. And as a specialty of you, you have really given the wealth of your knowledge in this FDP, ma'am. Thank you so much from the Department of Civil Engineering, Karunya University, and all the organizers for spending your valuable time with us, ma'am. Now we will have a question session, ma'am. I will ask the audience to post their questions in the YouTube, and Mr. Jerushan, he will coordinate with this, and he will read the questions from the audience, and you can answer the questions, ma'am.
No.
Over to Jerushan.
Hello, ma'am. So I'll read the question, ma'am. Yeah. So the first question is from Deepa Venkatesh.
Okay.
Kindly tell the difference between soft story and weak story.
Soft is very much related to the stiffness. Weak is related to the strength. If the, what I can say, the difference in stiffness of one story is less than the stiffness of the adjacent upper or lower story, then it is called the soft story. Similarly, when the strength of one particular story is much less than 70% or 80% of top or bottom, it is we call the weak story. It is very much related to the terminologies. Weak is related to strength and soft is related to stiffness.
Thank you, ma'am. Second question is from Aruna. While introducing double bars to the existing frames, will it won't decrease the strength?
I couldn't get you. While introducing
double bars to the existing frame, will it decrease the strength?
Double bar is not imparting any strength to the system. Double bars is to connect between the existing system and the proposed system. Double bar is what I can say, it's a interlinking element. It's only connecting the old element with the new element. That will dowel has to be designed to resist, but I can say take care of the shear occurring between these two elements.
Is retrofitting techniques also used in tall structures? From the same person.
What?
Is retrofitting techniques also used in tall structures?
Retrofitting structure, but it can be imparted to the tall structures too. Depends on what is the type of damage experienced by the structure. Accordingly, we have to decide. Depends upon the demand capacity ratio. We can adopt it for the tall buildings also.
Third question is from engineer MD Titukumar Hasana.
Yeah.
Is retrofitting will be possible after 7 magnitude earthquake?
That depends. Even if the earthquake happens, 7 magnitude earthquake happens at Chennai region, the intensity will subside when it is passing by the place called, what I can say, when it travels far away from Chennai region, the intensity will be less. Depends upon the type of damage experienced by the structure, we can retrofit it. There, what we have to do, we have to evaluate what is the residual strength available with the structure. If it is much sufficient enough, if it is 80% of the actual strength is again as a residual element, residual strength, we can go with the retrofitting.
The fourth question is from Dr. N. Anand. Nowadays, PT flat slab structures are widely used. So, any specific guidelines available for PT structure?
For retrofitting, they are asking?
No, ma'am. For post-tensioning flat slab.
Post-tensioning structures is always a rigid structural elements. And what I feel to our experience, this development of what type of shear cracks or flexural cracks in the PT slabs are very, very limited. The only deficiency or only problem what we are facing with the PT slabs are too rigid. It will not be undergoing. But in the case of diaphragms, we need a rigid structural element only. We are not expecting any type of what I can say ductility offered from the PT slabs. So if some retrofitting methodology is needed for PT slabs, I don't think it will be subject. There is a need for retrofitting of PT slabs.
So next question is from Nibesh Batula. How was retrofitting done for foundation and newly introduced column?
Oh, that is a good question. In case of column, that definitely will have some level of foundation, either an isolated footing or a strip footing or any other type of footing into the system. The existing column should be jacketed with reinforced concrete. Whatever be the reinforcement we are using in jacketing the reinforcement has to be extended towards the foundation. In the foundation region, for the existing foundation, we should provide a, what I can say, jacket or cover with a sufficient thickness of around 20 mm or 50 mm. And the reinforcement, additional reinforcement coming from the column jacketing should be extended towards the foundation jacketing, and it has to be concreted as it with an in situ concrete. I had a picture, but as the length of the presentation was big, so I avoided that. I can, yeah, tell me.
Okay, next question is from Jason Anton. Brief about wing wall.
What?
Brief about wing wall. Wing, W-I-N-G, wing wall.
Wing wall.
Yes, ma'am.
Hello.
Yes, ma'am. Wing wall.
Wing wall is nothing but like what I can say, our counterfort walls. When we are thinking about a retaining wall, we will provide counterfort walls like supporting the existing wall. We can provide additional wall on either side of the existing wall. That is what is called the wing.
Thank you, ma'am. And no questions so far, ma'am. That's all.
Thank you so much.
Thank you, ma'am.
Emma, I think I have answered whatever the question arised.
Ma'am, thank you so much.
I thought you had some question. Okay.
Ma'am, you are always clear in whatever you are explaining, ma'am. So we usually don't have questions in your class.
Thank you.
Yes, ma'am. And the way you explain the concepts is always informative, and even the last person can understand whatever you're teaching, ma'am. So
Thank you so much, Hema.
we are always proud to be your student, ma'am. And one very good thing which we appreciate in you is always you give credit to your students, ma'am. And I saw that in your presentation also, you were talking about us, whatever work we have done long back also, you were talking. Thank you so much,
It's
ma'am.
my proud to have you all with
Yes,
me.
ma'am. Yes, ma'am. So we will still make you proud, ma'am. Thank you so much, ma'am.
Thank you.
Thank you, ma'am. Thank you, audience, for listening to the FDP program and the lecture shared by Dr. Jaya, ma'am. We will meet again tomorrow at the same time, and we will be posting the links. Thank you, ma'am. Thank you all the audience.
Thank you so much.
Thank you.